More generally, we get linear models whenever something has a constant rate of change. Now, in many cases, we can think of this using proportions. For example, suppose that John drives 50 miles per hour. We want to write a linear equation relating the distance that John has driven to the time that he's driven. Right, we can think of this 50 miles an hour as 50 miles per 1 hour. And this rate at which John drives is a ratio, right, of time to distance to time. When we say that he's driving at a constant rate, or we don't tell you how his speed changes, we're telling you that this ratio, is constant. So distance over time equals distance over time. Cross multiply, we'll get distance times 1, that's just distance, is 50 miles times time. Right, this gives us an equation that you might have seen at some point. Right, this equation, distance equals rate times time. We can think of these rates, though in a more general way. It doesn't always have to do with distance. We might say, suppose Peter stuffs envelopes at a rate of 7 per minute. Write a linear equation relating the number of envelopes he stuffs to the time that he works. Right. So the number of envelopes over the amount of time is 7 envelopes per 1 minute. Cross multiplying, the number of envelopes is 7 times the time. When we're working with a rate like this, a rate that's just one number, we can, if we'd like, dispense with the cross multiplication and go straight to the linear equation. However, we have to be a little bit careful, because this quantity isn't always a distance. It might, as in this example, be a number of envelopes. And let's see an example where this quantity isn't exactly a time. Suppose we know that Lily's car gets 27 miles per gallon. Write a linear equation relating m, the miles she's driven, to g, the gallons of gas she's used. Right, now, thinking about the kind of equations we've been getting, we know that the correct equation is going to be either miles equals 27 times gallons, or gallons equals 27 times miles. How do we choose between these? Well, we have a number of choices. Our first choice is we could go back to the proportion, right? Miles over gallons equals miles over gallons. We see that cross multiplying, we're going to get this equation. We could also refer to our common sense. Right, if she gets 27 miles per gallon and she drives 1 mile, will she have used more or less than 1 gallon of gas? Right, she'll have used less than 1 gallon of gas. But if we use this equation, driving 1 mile will use 27 gallons of gas, and that doesn't make any sense. So again, our common sense tells us we should choose this equation. If we're not sure, we can always check with the proportion. Okay. Now this gets a little bit more complicated. Let's talk a little bit more about Lily's car. So we're starting out with the same car. Lily's car gets 27 miles per gallon, and its tank holds 12 gallons. Suppose Lily starts a trip with a full tank of gas. We're going to write a linear equation relating the number of miles that she's driven to not the number of gallons of gas that she's used, but the number of gallons of gas that's left in her tank. right? So, in solving a problem like this, we wouldn't necessarily write out all of these details every time. But we are allowed to write out as many details as we'd like to help us understand the situation. The first fact that occurs to us is 27 miles per gallon tells us about how much gas Lily uses, not how much she has left. But I think we understand that pretty well, right? The amount of gas she has left will be, well, she starts with 12 gallons, and then she uses some of it up. So the gallons she has left will be 12, and then take away the gallons she uses. We just need to figure out what this is. Now we can go back to that proportion, right? We know that the miles she drives will be her miles per gallon times the gallons she uses. Right? 27 times the gallons she uses gives us M. We could think divide both sides of this by 27 if we'd like. 1/27th of the number of miles she's driven will be the number of gallons she uses. Alright, so now we're in a position to actually answer this question. Right, the gallons she has left will be 12 minus, how many gallons has she used when she's driven M miles? She's used 1/27th M gallons. Right, again, this expression is gallons she's used. Now this equation form, what we have equals what we start with minus what we use, or what we have equals what we start with plus what we gain. These are very common forms for linear equations to take. I'm going to have you write out an equation that uses one of these forms. Brian is running from a bear. It starts out 50 feet from him and closes on him. That is, it decreases the distance from him at a rate of 3 feet per second. Write a linear equation relating S, the amount of time that Brian has been running, and D, the distance between him and the bear. Pause the video and try this now. Okay, well, the distance between Brian and the bear, D, it starts at 50 and it decreases, right? The bear is closing on him, it's catching up. So we're going to subtract. Do we want feet equals feet per second times seconds? Yeah. So we'll have 3 times S. Right, for every second that Brian runs, the distance decreases by 3 feet.